I'm Torben Grell, and I was privileged to do an interdisciplinary PhD within the Pilot to Paddock project. My PhD was literally to investigate commercial available technology to tackle the environmental issues associated to dairy effluent. We tried to find technical solutions to promote a circular economy on farm to reduce their dependency on fertilizer and energy intake. Our approach was to implement a solid-liquid separation to separate the solids out, generate a particle-free filtrate, or at least really tiny particles. So to increase separation efficiency, we tried to enhance it chemically. We mineralized the soluble phosphorus into a particle which we were afterwards able to filter out, which resulted in a phosphorus removal of 90%. But we diverted in only 2% of the initial mass. We also achieve emission reduction potential by diverting volatile solids or solid material away from the effluent ponds. Through the knowledge, predominantly through the wastewater specialist Stefan Teit, we achieved that, and that are fantastic results which no one have achieved in a commercial operation system on a dairy farm yet. And the farmer is, of course, able to recycle the nutrients, which is a primary driver of the farmers. We took it a little bit further to also investigate what is the impact of the separated fractions when we apply it to soil. So we took soils well characterized from UWA, and we incorporated my separated solid products with flocculant, without flocculant, all the different treatments. So we have the pure separated manure, we have it combined with flocculant, and we do have the calcium phosphate precipitation, which removed the majority of the phosphorus, testing here in combination with flocculant, which then translated into my second part, where I investigated the biochemical methane potential of the entire Australian dairy sector, where I traveled across several states and investigated different dairy farms. The predominant system we are running in Australia is pasture-based, so the cows are most of the time out in the paddocks, which means we only capture a small amount of manure. Meanwhile, if they are in intensified systems, we capture a lot of manure. By the individual characterization of the manures, we found out that cows fed with pasture are actually, the manure have a lower methane potential than cows fed with grain. And we do think it is related to the proteins, but through my cooperation with UWA and the experts in the microbial investigation, we actually identified that the microbial pathway is the primary driver and worthwhile to exploring further. This means we need different strategies for individual farm circumstances to either maximize the methane yield if recovery technologies are there, or minimize the released methane if recovery technologies are not in place. To literally give the farmer the easiest, most efficient technology they can use and successful continue operating. Where I'm actually really excited in is taking the research, the knowledge out of the laboratory and implementing it into the real farm world or agriculture sector.